Good morning. We are going to do 2.1, day one material, applying Vertex Form. And we're going to be learning how to use Vertex Form and how to combine that with what we already know about transformations. So for the notes today, you have a handout in your packet that looks like this. Translations of quadratic functions. I'm going to be referring to that. As we go along, we're going to add some details to it, so you might want a colored pen to do that. Okay, so first off, what is vertex form? Okay, so there's actually a vertex form for absolute value, and there's a vertex form for parabolas. So vertex form for a parabola is y equals a times x minus h quantity squared plus k. For an absolute value function, it's y equals a absolute value x minus h quantity plus k. In both of these, if the a is positive, it opens up. The parabola will be curvy. The absolute value graph will be a V shape. If a is negative, it opens down. The vertex in this form is wonderful. You can pick it right off the form. It's h comma k. For both of these, it's h comma k. And the a can also tell you how steep or flat looking the curve or the V is going to be. If a equals exactly 1, it's going to have what we say a medium bell, which means you'll have a vertex and then it will go through the corners. In the case of an absolute value graph, it will look like a V going through the corners. In the case of a parabola graph, it will look like a curve. That's a medium bell. If a is a fraction less than 1, you're going to get a wide bell. So 1/2, negative 1/2, positive or negative. If it's less than 1, you're going to get a wide bell. And if a is greater than 1, you're going to get a narrow bell. And they get narrow really fast. So if you have an a value of 3 or 4, that's going to be an incredibly narrow figure. So first thing we're going to look at is how vertex form is related to the base functions that they start with. Okay, so your base function for a parabola is y equals x squared. Your base function for absolute value is y equals, absolute value of x. Okay, let's look at your transformations page. And this is a summary of what we've actually covered. You should have notes on this already, but a horizontal shift is a horizontal translation, and it's what's being done to the x. So if it's x plus an h, the graph moves left. If it's x minus an h, the graph moves right. So the x values are always backwards from the sign that you're looking for. Now, for the vertical shift, that's the k value, which is added to the outside. And if k is negative, so you have a negative k, it's going to translate down. If you have a positive k, it's going to translate up. And what you see is what you get. Okay, now reflections. For reflections, reflection across the y-axis. So this is your y-axis. And the reflection of the y-axis will add a negative into the graph. But since that gets squared, it doesn't actually change the shape of the graph because it's already symmetrical. So the curve just flips right over. Now, reflection across the x-axis is different. Here's your x-axis. So for this one, you're going to have a negative in front of the x minus h parentheses, plus k. And if you have a negative in the front, it's going to flip from the top to the bottom or the bottom to the top. And again, this negative is outside of the parentheses. All right, horizontal stretches and shrinks. Remember that horizontal stretches and shrinks are backwards. So if it's a 1 over a b being multiplied by the x, so 1/2 x, x over 3, 1/4 x, then it's going to be a horizontal stretch that's getting bigger by a factor of b. If your x is being multiplied by b, then it's going to be a horizontal shrink by 1 over b. So you're always looking for the reciprocal of what you're looking at to decide if it's getting bigger, which would be a stretch, or smaller, which is a shrink. And a stretch will make the graph skinnier. Think of pulling taffy. It gets skinny. And a shrink is like squishing it back down. It's going to get wider. Okay, for vertical stretches and shrinks, you're looking at the number a outside of the x squared. So if you have y equals a times x minus h squared, that is going to be a vertical stretch by a factor of a. If you have a 1 over a in front of that, that x minus h, it's going to be a vertical shrink by 1 over a. So unlike the x's, which is the reciprocal or backwards, again, the vertical, what you see is what you get. Okay, so let's use those rules to describe what's being done to the base graph. Okay, here's our first example. Let's say you've got f of x equals 2 times x plus 1 squared, and you're being asked to describe the transformations. And so remember that your base graph, the one that you start with, is f of x equals x squared. Everything else that's being done to it is a transformation. And as you describe, you always want to go inside to out. Okay, so looking inside, we have an x plus 1. The x plus 1 is a horizontal translation, and it's backwards, so it's minus 1 to the left. Okay, and then we've got a 2 sitting out front of the x plus 1 squared. So it's out front, so this is a vertical transformation. So a vertical, and this is being multiplied, so you're talking stretch or shrink. In the case of vertical, what you see is what you get. This is a vertical stretch by 2. So you just keep going from inside to outside. You do horizontal translation, and then you do horizontal reflection, and then horizontal shrink and stretch, and then you do the same things in the vertical. Vertical translation, vertical reflection, vertical shrink or stretch. So it goes inside to out. Okay, so let's do another example. Let's say that you have a vertex at 1, -4, and your parabola is passing through the point -2, -1, and you need to write the equation of the parabola. Okay, so our formula, again for vertex form, is y equals a times x minus h quantity squared plus k. Now, what they've supplied us with the vertex is the h and the k. We got that taken care of. And we can use this as a temporary point for x and y. So if we substitute all those in, we should be able to get an a value, which is the one item that we don't have and can't be calculated with an outside formula. So I'm going to fill in the vertex for x and h and k, and then I'm going to use the -2, -1 for a temporary x and y. All right, let's do that. So -1 for the y equals a times temporary x, which is -2, minus my h, which is 1, quantity squared, and then plus k, so -4. And then I'm going to solve for a. Okay, inside to out, -2 minus 1 is -3, squared is +9. So -1 equals 9a minus 4. I'm going to go ahead and solve with a on the right. So add 4 over to the left. You get 3 equals 9a. Multiply both sides by a 9th to get the a by itself. And 3 over 9 reduces to 1/3. Once you've got your a value, now you can write your equation. Y equals 1/3 times x. It's -1 quantity squared, and then -4 for the k. It's always the opposite sign for the x and the same sign for the y. And that is our answer. Okay. Let's do another example of a question. Example 3. Let's say that they've given you the equation in standard form. Y equals 2x squared minus 4x plus 3. And they want you to change it from standard form to vertex form. So what you're going to need to do is complete the square. So that you have your x minus h quantity squared. Okay, so in this case, we're going to do x's on the right. So we're going to subtract the non-x's over to the left. That gives us y minus 3 equals 2x squared minus 4x. Leave a space, leave a space. Now, I do have a scalar, so we're going to need to take everything on the right side, divide it by 2. The 2 goes out to the front, and I'm left with x squared minus 2x, leave a space. Over here, I have a number I'm going to be adding in there, plus y minus 3. All right, now it's time for our magic formula. Our b value is a -2. So we're going to go b divided by 2 quantity squared. So -2 over 2 squared is -1 squared, or a 1. So we're going to add 1 on the right. And then remember, because you have a scalar, you didn't just add 1, you added 2 times 1. So you're going to add a 2 over there to even it out. So now what do we have? I have y, and 2 minus 3 is -1 equals 2, and then complete the square, you get x minus 1 squared. So we are almost in vertex form. The last thing we need to do is add 1 over to the right, and you get y equals 2 times x minus 1 quantity squared plus 1. And we have our vertex form. Okay, so we're going to extend this question. We're going to identify some of the key structures to this. I don't want to take time to graph this, so I'm just going to really quick sketch kind of what the shape is. So my vertex is going to be 1, 1. And A is a +2, so it's going to be going up from there. Okay, so for starters, the axis of symmetry is the vertical line that goes through the vertex. And just like for standard form, the equation for the axis of symmetry is the same thing as the x coordinate of the vertex, which in this case is 1. So x equals 1 is my axis of symmetry. Okay, domain. Well, the arrows say infinitely left, infinitely right, so that hasn't changed. So -infinity to +infinity. Range. Okay, so this one's going to have a bracket because the lowest point, the y value, is a 1. It goes from 1 up. So our range is a bracket because 1 is actually a value on the graph up to +infinity, just like what we've been doing. All right. Maximum or minimum. This is when we're going to be adding. And the format for maximum and minimum is you say max or min of, and then you give your y value, y equals a number, at, and then x equals a number. So the y, this is your max or min, and the x is the location. Now in a parabola, it's either going to be opening up or it's going to be opening down. It's either going to have a maximum or a minimum. So on the graph that we have, this is definitely a minimum value. It has a lowest value. So we would say it has a minimum of y equals, and I'd give the y value, which is 1, at the location is x equals 1. And that's its minimum. All right, just to make sure you've got this, let's use this little mini graph here. Let's say that the vertex is 5, 3. Okay. So this graph has a maximum, not a minimum, because it has the highest value. So we would say it has a maximum of y equals, and the y value is 3, and this occurs at x equals 5. So for this little graph, it would have a maximum, not a minimum. Okay. The last thing I want to show you before we wrap this up, this is example 4, is how do we get a graph back into standard form? So let's say that you've got your graph y equals, I'll make this a 2, times x plus 1 quantity squared minus 4, which is vertex form, and I want to change it back to standard form, which if you'll remember is y equals ax squared plus bx plus c. So basically what you're going to do is simplify out the parentheses. Now, you can't distribute this too. You've got to do this part first. You're going to multiply x plus 1 times x plus 1, which is, let's see, x times x is x squared. X times 1 is x. Now distribute the next number. 1 times x is x. 1 times 1 is 1. This is why we practiced multiplying together when we were factoring. Add those up, x squared plus 2x plus 1. Now, we just squared it, so the 2 is still in the front, and the minus 4 is still at the back. So once you square it out, now you're going to distribute the 2 through the trinomial. So y equals 2x squared plus 4x plus 2. And the last thing to do is put your two numbers together. So y equals 2x squared plus 4x minus 2, and you are now in standard form. So vertex form to standard form, multiply everything out. Standard form to vertex form, complete the square. All right, that's the end of the notes. I hope that was helpful. Have a good afternoon.